Okay, let us discuss this reaction. So you have to write down the mechanism for the following reaction. You have OH here, and this side there is no OH. So this is a fast change. You see another change is there is a double bond here, and there is no double bond here. Now once again we have another change. There is a double bond, but there is no double bond. It looks like this double bond has shifted to this position. One change it looks like. Now another 6 changes. You have a bromine that is added. So what are the changes that is taking place? So it looks like this OH has gone and the medium is acidic. So it looks like this reaction basically loses one H2O molecule. So this is a loss of one molecule of water. Another change, it looks like there is a shifting of double bonds. So another change I can think. So this is a shifting of double bonds. There is a shifting. So it looks like there is a shifting of double bond. Are you getting? So this is another change that you can think of, shifting of double bond. Now any other change you see, there is a nucleophile, it looks like Br minus has attacked on some nucleophile. So it also looks there is a Br minus attack. Are you getting? And of course this on attack on carbocations, there must be a carbocation that reaction, and maybe there is a rearrangement of carbocation that is also possible. So let us try to see. What we will do is we have this molecule. So you have this molecule. And let me make this one. So here you have OH, you see here, so there is a OH, so I have to add OH, and then you have double bond C double bond O. So this side you have a double bond, this side you have C double bond O. Let me expand the thing, COOCH3. Now the medium is acidic, so you have to have H plus. Now see, what I have to do is I have to lose H2O molecule. So what can I do? I can protonate this oxygen. Are you getting? So if I protonate this oxygen, so I have H plus. So this oxygen gets protonated. So if I do protonation, what I will have, I can write here. So this is my, after protonation step, I can write there is a benzene ring. And this gets protonated. So you will have OH2 plus. OH2 plus, and there is a double bond here you have, and then you have C double bond O, OCH3. The next step is simple. If you lose one H2O, so there is dehydration step. It's a very simple step, very common step. If you lose one H2O molecule, you have something like this. There is a carbocation, and now you can see in the next step you can do rearrangement of carbocation. So you can shift this double bond here. If you shift this double bond here, what you will have? So let us say you can basically write slightly something like this. So you can shift this double bond, you will have a benzene ring. It's difficult to write the benzene ring many times. So you will have a double bond here. So if you shift this double bond here, and now what you will have? You will have a carbocation that is formed, perhaps primary carbocation. So this step is an unusual step. So what is happening? I am forming a carbocation. It's a primary carbocation. Initially it was a secondary carbocation. Resonance stabilized through this benzene ring. But now I am forming a carbocation. And that's why maybe this carbocation is not formed. It's formed and it is attacked by the bromine. So this carbocation, as soon as it is formed, it is attacked by the bromine minus. So this carbocation is basically can't be isolated. So this carbocation can't be isolated because it's a very unstable isolated. So reaction is something like this. So carbocation is forming and Br minus is also attacking. So at the same time, this carbocation migration as well as attack of Br minus both happen at the same time. You see, if it happens, so you will have the product. Here you have a benzene ring and double bond, and here you have one bromine. And then this side you have C double bond O, CH3, OCH3. Simple. Are you getting around? Let us discuss the next problem. So this is again writing mechanism. Let us write down the mechanism for this reaction. Of course, the medium is once again acidic. So you have H plus and H2O. So medium is acidic. So you have to write down the product in the acidic medium. Once again you have to look the changes. So what are the changes? So this is a good idea. So you have to look the changes. So this is a good idea. Always you look the changes. Whenever you have a mechanism writing kind of problem, it's better to write down the changes. So see what are the changes that is taking place. You see OH that is gone. Or you can say this OH, this carbon, 1, 2, 3, this carbon is connected to the third number carbon. So it looks like this oxygen is attacked on this carbon. And as you this can be done by losing one H2O molecule from here, and then you get the carbocation. You just do one rearrangement from their carbocation, so hydrides it, you get the product. Let me write this mechanism, easy one, so I can go fast. So you have this ring. Here you have CH2OH, and what I have to do is I have to protonate this oxygen in the first state itself. So you have OH. Now let us protonate this oxygen. So if I protonate this oxygen, what I will have? I will have this ring, and then I will have here OH, and then here I will have OH2 plus. Now basically not OH2 plus. In the next step, if I lose H2O, then I will get. So let us say I will have OH2 plus. And now if I lose H2O molecule, so I will get a carbocation. So I will have a carbocation. So this molecule, and there is a OH, and then here you will have a carbocation. And now in the next step I can do hydride shift. So if this hydrogen shift at this position with these two lone pair of electrons, so this is a hydride shift. So this is a step. So I am writing this step. So this step is a hydride shift step. So I can write slightly better way. So this is a hydride shift, or you can say minus H shift, hydride shift. So it's a negative hydride, so minus charge on a hydrogen. So that's why it's a hydride. Oxide, similarly you have a hydride. So you have double bond here. And if you do hydride shift, you will have here something like this. There is a OH. And now what you will do in the next step? Only one thing you can do. So attack of this lone pair here. So if you follow this step, you will have simply this compound. So there is a double bond here, and this carbon connected with oxygen. So let us write oxygen here and connect this carbon and this carbon, and this carbon also have two groups. So this is the same thing. Are you getting? So you see the product, final product, it's the same thing. This carbon and this carbon is connected by one oxygen, and this carbon contains two methyl group. So you see this carbon. So oh my god, it looks like this oxygen has basically connected to this. So there is no hydride shift. So I am doing, so you see, writing the product is to follow the product. Writing mechanism is followed by product. So this is not attacked by us. So there is no hydride shift. So basically I have done a wrong step. So in this case there is no hydride shift. So I have to have up to here itself. So I can rub this one. So let me rub this one. So whole thing is basically wrong. So there is no need to do the hydride shift. So there is no hydride shift. Are you getting or not? So this is a no hydride shift. So basically there is no hydride shift. Okay. So this arrow is also not there. There is no hydride shift. Are you getting? So and then as to send things are then simple. So there is no hydride shift. So what you will do? You will have this oxygen lone pair. If this oxygen lone pair attacks on this carbon, and then you will get the desired product. Are you getting or not? So if you attack this carbon, so you will have this, and then you will have double bond, and this oxygen and it's connected to this oxygen, you will have OH plus, and then you can lose H plus, you will get this product. Are you getting or not? So this product you are getting after the loss of H plus. Are you getting or not? Simple. So I can rub this one. So these things are not there. So let us copy fast. So this is not there. Are you getting or not? So this is the wrong step because I have done hydride. So basically that hydride shift is not possible because what you are doing, okay, that is possible sometime, but the problem is, you see, if you do this hydride shift, we are getting 3-degree carbocation. That is a good idea, but you see, if you do hydride shift and you get the 3-degree carbocation, but the problem is the epoxide form is a 3-membered ring. In this case, epoxide form, it is slightly less strength. So this is less strength, but in that case, if you form epoxide here, that is slightly more strength, and maybe that's why epoxide is formed. So not the 3-membered. Are you getting? Simple.